In this lesson, we're going to go over how to make or 3D model the Titan 88L. Just like all the parts in the Rocket series, this is a turn part, so you would actually manufacture this part on a lathe. Because of this, we are actually going to make this part as a revolved part. So let's take a look at the blueprint. Well, on this print, this area right here, this is going to be our front view. And notice the overall diameter of our part is 950 thousandths. In our front view here, we have section B, kind of dividing this part in half. Underneath this part, we actually see that section B to B. To the right of our front view, we have our right view, and there's a little bit of clarifications that there needs to be some chamfers on the outside of these flanges. There's a little radius on the bottom of here. There's a corner radius on the relief behind our threads. And then on top of it, the lead and exit point for our threads also needs to be chamfered. Looking down at our section view here, this tells us the distances for all these little features. It's also giving us this diameter here to create this ball feature. Right down here we have a detail A, which gives us a little bit better clarification of our diameters for the thread relief, and then also for our major diameter here for our threads. And then over to the left we have an isometric view, which offers a little bit better clarification of what the part is going to look like as a kind of a visual representation of it. Up in the upper left hand corner we have this external data sheet. This is basically when you manufacture the part. This is information that's derived from the machinist handbook. These are mins and max values that you are going to actually measure, that are measuring across these threads here. These particular values really don't hinder the part being designed in Fusion 360, but it will when you actually manufacture it. So let's jump over to Fusion 360. Alright, we're over here in Fusion 360. And we're going to start drawing up the Titan 88L. This particular part, because it is a lathe part, we're going to make it as half the part. So I'm going to start with a line here. This particular part, I always start on my top view. And what I'm going to do is I'm going to anchor my line right off the datum location. The overall length of the part is 1 inch 920 thousandths. So that's where I'm going to make my line at. From here, what I'm going to do is I'm just going to put some rough sketches in. They don't need to be perfect. Just kind of needs to follow the outside of my part here. Okay. So this is kind of the outside of my part. Again, it doesn't need to be perfect. We're going to add some dimensions to it later, and then we're also going to add that circle over here, and that'll give us that radius. So what I'm going to do is I'm going to take a couple seconds and I'm going to add some constraints to this. That way it makes this part a driven part. We know that the diameter of our flange from this location to this location are the same. So I'm going to add a vertical and horizontal constraint, constraining that point and that point together. Same thing with this flange, that point to that point, and down here for our thread reliefs. By doing this, it limits how much measurements I actually have to do. And then later on, if I have a customer who wants to alter some stuff, the part will actually start to drive itself. So we only change one measurement at a time, and then it'll drive the entire part. I'm going to jump over into dimension mode by hitting D on the keyboard. And we're going to start adding in our dimensions. So backside of our thread relief is 300 thousandths. to this flange, 365, outside of the flange, 565, inside the flange, 1 inch, 365, outside the flange, 1 inch, 555, thread relief, 1 inch, 620, and we have our overall length of our part. Just going to move that measurement up. So now we can clearly see all of our dimensions here. Now we're going to do our radial dimensions. D on the keyboard, coming from our datum. On the print, it's indicating that the major diameter going across our threads is 362 thousandths. Well, we need to divide that number by 2, so 0.362 divided by 2 gives us our diameter. Our thread relief is 260. Again, divide that number by 2. Flange diameter is 950. Divide that number by 2. This particular line in the center, I'm just going to drag that in. I'm not going to put a dimension to it yet, because that circle in the center will actually drive that measurement. So right now, we have our rough sketch. We're going to add that circle in right now. So I'm not 100% sure if that circle is going to be in the exact center, so I'm going to stay away from the midpoint on this line. So I'm going to draw my circle kind of off center here. We're going to let the measurement drive the part, and it's indicating that the diameter of this circle is 950 thousandths. I'm going to add my dimension to that at 965 and drive that part. So what I'm going to do right now is I'm actually going to delete this blue line. So all I did is I highlighted it and hit delete. And then what I'm going to do is I'm going to take these endpoints and I'm going to add a coincident from here to the circle. So coincident constraint from here to the circle, here to the circle. And just snap those edges right up to the circle. Then I'm going to enter into trim mode. I'm going to trim off the extra portions that I don't need of that circle. Just like that. And then now we're going to add in that radius coming right around here. So fill it. We're going to click on those two locations. According to the print, that needs to be 50 thousandths, so just under a 1/16 of an inch. Now notice when I deleted that horizontal line, some of my lines turned blue, which is indicating that they are not fully constrained. So let's click on some of these and see what's happening here. So notice when I'm dragging these things around that we just need to add in some constraints. So I'm going to add in some vertical, horizontal. I'm going to say that this line is vertical, and notice, or excuse me, that line is horizontal. And just by clicking on that one, all of our other lines turn black. So we were just missing one constraint there. Okay, we got our profile sketch. Now we're going to revolve the part. Solid to revolve. We're going to revolve this profile around this axis and then hit OK. We have our solid body now. We're going to add in all those missing chamfers so we can add in our threads, modify down to chamfer. We're going to look at the thread chamfers first. So it says there's 4 of them. So we know that both the lead in and the exit point for our threads are going to be chamfered at 35 thousandths at 45 degrees. That takes care of those. In addition, we're going to right click, repeat chamfer. We're going to click on these outside edges of this flange. Those need to be chamfered at 10 thousandths at 45 degrees. And then lastly, in our detailed view here, this edge and this edge need to be have a little corner fillet there. Modify down to fillet. This corner, I'm going to choose that corner. Be mindful of which lines you're picking right now. This corner and this corner. Now again, these little corner fillets would be derived by either the parting tool or the grooving tool that you're using to create that thread relief. And the print's indicating that that needs to be 20 thousandths max, so we can't go over 20 thousandths. Most of these tools will have about a 10 thousandths radius on them. Last thing, we're going to add our chamfers to both sides here, or our threads to both sides. Create down to thread. We're going to click on this face and this face. If it doesn't allow you to click on the other face, you can hold down Control, click on the other face. We're going to use modeled threads on this one because we want to look at our threads and actually see what they look like. And as indicated on the print, these need to be 3/8. So decimal equivalent of 3/8 is 375 thousandths. 3/816, class 2A. And these are right-handed threads. Press OK. And we have our part. It's a good opportunity. Check your print. Make sure you got all the features on there. This lesson concludes how to make the Titans